To what group or to what period or to what block do the elements belong to? Some will go and start calculating 2 plus 2 plus 4 will give you 10 plus 1, which is 11. This is actually sodium. Then you memorize and say that sodium is in group 1. This will take you more time and you might get confused if you are memorizing. See what you will do. See this last thing here. This last figure, this last unit shows everything. This is group 1. This one shows that sodium is in group 1. This is the period to which this element belongs. So sodium is in period 3 and also in what? Block S. Very quick and you solve your problem. So if the right configuration for you, welcome to Sir Majesty Easy World Science channel. If you have not subscribed to my channel, please endeavor to do so. I beg of you, subscribe and share this video. Expand this science community. In this video, I'll be teaching you shortcuts in chemistry calculations, how to make some calculations and how to answer some questions very fast. This is actually the part 2. I have done the part 1 on this channel. You search for the video and also watch it. It will help you. First of all, I want to start with, sometimes you see equations or questions on electronic configuration asking you to identify the period and the group. So we are looking at chemistry shortcuts part 2. First of all, in the configuration you might see something like 1s2, 2s2, 2p6, 3s1, and the question will be asking you to what group or to what period or to what block do the elements belong to. Some will go and start calculating 2 plus 2 plus 4 will give you 10 plus 1, which is 11. This is actually sodium. Then you memorize and say that sodium is in group 1. This will take you more time and you might get confused if you are memorizing. See what you will do. See this last thing here. This last figure, this last unit shows everything. This is group 1. This one shows that sodium is in group 1. This is the period to which this element belongs. So sodium is in period 3 and also in what? Block S. Very quick and you solve your problem. So if the right configuration for you to identify the group and the period, you just look at the last configuration digits. Now, what if we have similar thing? If you have 1s2, 2s2, 2p6 and 3s2. To what group does this belong? You have, this is belongs to group 2, still S block, and then still in period 3. Now, there are few exceptions to this, I'm telling you. What if S did not end it? If S did not end the configuration, the group changes. You add the number on the orbital that ends it to the S following it. See what I mean? For example, we want to do that of chlorine. Chlorine is number 17, which is 1s2, 2s2, 2p6, 3s2, 3p5. Of course, this is 2 plus 2, this is 10, 12, 17. Now, you circle these out. Chlorine is in P block in the periodic table. It is in period 3, but not in group 5. Rather, it is in group 2 plus 5. You sum it up. 2 plus 5 is 7. So when it is not S, because look up here, this is P and this is S, this is S. So when S ends it, the last digit gives you the information, but when it is P, you sum to the next, at least for the first 20 elements. Understood? So let's take another one. Let's assume we want to write carbon, which is 1s2, 2s2, and 2p2. So what is this is the block, P block, and here is the period. So carbon belongs to period 2 in the periodic table, but group what? 2 plus 2, group 4. So that is how to answer such question. This is a pure cheat on what we use. Then, what if the configuration is done in this format, in a situation whereby you are asked to find that of sodium using the distribution in the shell K, L, M. Sodium is 281. This one also, the last thing here is the group. The valence electron is the group. Then what's the period? 1, 2, 3. The number of digits you wrote is the period. So I wrote how many digits? 1, 2, 3. So sodium is in period 3, but group what? Group 1. So that is the number of shells shows period, while the last electron shows group. So what if you have KLMNO, or let's stop there, 2882. This is calcium for you. What should be the period? Period 1, 2, 3, 4. Period 4, group what? Group 2. This one doesn't tell you the block, but this tells you the block, the group, the period. So it's more informative. Now, what if sometimes we are faced with methods of collection of gases, or rather, which of the following gas is lighter or heavier than air? You might meet with this question in exam, where you are required to identify a gas that is heavier or lighter than air. There are many gases in chemistry, and if you want to memorize the gases one after the other, saying this one heavier or lighter, you might get confused. So I'm going to give you a little cheat, and that is the next easiest possible way to solve that question. So we are going to compare density of gases and that of density of air, though air is still a mixture of gas. Now we are going to use, you just say this number 28.8. 28.8 gram is what my analysis and from my calculations prove that 1 mole of air, for example, though is a mixture, should weigh 28.8. So the weight of air, you take it at 28.8 gram. Therefore, if they give you any gas, if the molar mass of that gas is lower than this number, the gas is lighter than air. But if the molar mass of that gas is higher than this number, 28.8, that gas is heavier than air. So you save your time memorizing. Simple. What you have to do now is just say 28.8, and that is the density of air. Now, to check, what if they ask us ammonia? Is ammonia lighter or heavier than air? Whereby we know that nitrogen is 14, hydrogen is 1. So check the molar mass. This should be 14 times 1 times 3. That gives us 17. So ammonia is 17. Is 17 lower or higher than 28.8? It is obvious that 17 is lower. Therefore, ammonia gas is lighter than air. Ammonia gas is lighter or less dense than air. Lighter than air, or what we call less dense than air. This will not only tell you the gas that is lighter, it can also predict for you how many times such gas is lighter or heavier than air. How many times is ammonia lighter than air? You can simply say 28.8 divided by 17, which will give us roughly about 1.6 or 1.7 times, roughly 1.7 times lighter than air. We take another instance. What if they give you something like carbon 4 oxide? Carbon 4 oxide, is it heavier than air or lighter than air? Carbon is 12, oxygen is 16, then times 2, which will give you 32. At the end, we have 44. So the molar mass of carbon 4 oxide is 44. Is it bigger or higher than 28.8? It's obvious that 44 is higher than 28.8. Therefore, this particular gas, carbon 4 oxide, is heavier than air, or rather, it is more dense or denser than air. How many times? Always use the higher number. Use the higher number and divide it by the lower number. I did 28.8 divided by 17 here. Why? Because 28 is more than 17. But here, 44 is more. For you to find out how many times carbon 4 oxide is heavier than air, you say 44 divided by 28.8. So checking the calculator department. Okay, we have that 44 divided by 28.8 is 1.5. So This is, so carbon dioxide is about 1.5 times heavier than air. So this will help you save much time in chemistry, especially in objective questions, and answer the question and go your way. What about chlorine gas? If the question says, is chlorine heavier or lighter than air, you take a look at chlorine is diatomic, of course, which is chlorine is diatomic, and 1 chlorine is 35.5, then times 2, which shows that 1 chlorine gas, 1 mole of chlorine gas is 71. Therefore, it's obvious that 71 is far more than 28.8. So what do we say? Chlorine is heavier than air. And then, how many times? 71 divided by 28.8, which is approximately 2.5 times. So chlorine gas is 2.5 times heavier than air. Let's take a look at hydrogen. Hydrogen is where 1 hydrogen is 1, so that the mass of 1 hydrogen gas is 2 grams. Therefore, is hydrogen lighter or heavier than air? It is lighter than air because 2 grams is far more less than 28.8. How many times? You say 28.8 divided by 2, which will give you what? 14.4 times. So hydrogen gas is about 14.4 times lighter than air. How did I come about the 28.8 grams? You watch the video here, you see there on the screen. I have the proof. I proved why I use that 28.8, having known the density of gas and most of that information from Amedio Avogadro and Stanislaw Canizaro. I was able to come about that this is the weight of 1 mole of air, even though air is a mixture of gas. So now, how do we collect these gases? It is also found in that video. Gases that are heavier than air are generally collected by downward delivery and upward displacement of air. So downward delivery is the same thing as upward displacement. Then for gases that are lighter than air, they are collected by upward delivery and downward displacement. You get more details if you watch this video. Now, another thing is sometimes we are faced with radioactivity calculations where you are required to know half-life and then the number of masses remaining. Student might find this difficult. I'm going to give you the cheat, the shortcut on how to solve any calculation involving half-life, the mass of radioactive isotope remaining. So let's go. So we see shortcuts on half-life and the mass of radioactive isotope. So we might see even the decay constants, the rate of decay. In this case, you are going to use the formula which says that 1 all over 2 raised to power n over half-life. This will be half-life times original mass stroke original number of atoms, whereby the definition of term says that n is equal to the number of years or the period of time given, number of years we are calculating for stroke the period of time we are calculating for, where HF is the what? Half-life. So you are going to say 2 raised to power the answer. That's why this is in brackets. So let's quickly take a look at an example to this, and we use this formula to solve and go our way. So here you bring our formula which says 1 over 2 raised to power n over half-life times original mass. That is mass remaining or atom remaining. If I change this to number of atoms, you still use the same formula. Mass remaining. If this is in minutes, you still use the same formula because this is time. Time can be in minutes, seconds, years, or months. So now, mass remaining is equal to 1 over 2 raised to power n all over half-life times original mass. So interpreting this, we now say 1 over 2 raised to power. What's the number of years we are calculating for? They say after 45 years. Divide the 45 by half-life, which is 5 years. then times the original mass, which is 14. Now, 45 divided by 5 is 9. What we have now is 1 over 2 raised to power 9 times 14. 2 raised to power 9, of course, is 512. In normal, yes, of course, 2 raised to power 9 is 512. So we are now dealing with 1 times 14 is 14. At the end, we have 14 over 512. So let's check with our calculator, which is 0.0273 grams. That is our answer. That is for calculation of half-life. Then, in some cases, you might be given a nuclide with a charge, asking you how many electrons, how many protons are remaining. Let me settle that for you. See what I mean? Giving you a nucleus or a nuclide or an atom with a charge. For example, if you have calcium and they say +2 here, and 20 is here, and 40 is here, the question says how many protons are here. Obviously, this number here is called atomic number, which is the number of protons. So over here, protons is only 20. Then how many neutrons? The number here is called mass number, and mass number is the sum of protons and neutrons. So we already know that now protons alone is 20, but when you sum it with neutrons, it gave you 40. Therefore, neutron is equal to now mass number minus atomic number. That is 40 minus 20. Just use this 40 and minus it here, such that the number is 20. Then how many electrons? Normally, we're supposed to have 20 electrons, but because of this charge, +2, you do negative mathematics, you do negative counting. So what you are needed to do here is that if you see plus, you minus. If you see minus here, you add it to this. What I mean, don't say 20 plus 2. No, rather, because we see +2, or 2 plus, the number of electrons will now be this 20, not here, this 20 minus 2. So the total electron is 8. So what if we have another nuclide? In this case, here is 11, that's sodium, of course, and here is 23, and here is plus. So how many protons, class? 11. How many neutrons? 23 minus 11, which is 12. Then how many electrons? Simple, 11 minus 1, because there is only plus, which is 10. Now, what if we have something like this, and there is 2 minus here, and then 8 over here? How many protons? How many protons are here? 8. Then how many electrons? Because I saw 2 minus, I will now add. Electrons are now 8 plus 2, because this is minus, I'll just sum it up, which will give you 10. This means that sodium ion and the so-called oxygen, this is oxygen, of course, 16 will be here. If 16 is here, it means that neutron is also 8, because 16 minus 8. Now, this charge is where my interest is. If they give us this charge, just do negative mathematics. If you see minus, you add to this. If you see plus, you minus from this. Therefore, sodium ion and the oxygen ion are isoelectronic. What do you mean by isoelectronic? Meaning they have the same number of isoelectronic. That's, they have the same number of electrons. The same thing is applicable here. If you have 13 here and 27. So how many protons are here? 13. How many neutrons? 27 minus 13. How many electrons? You just say 13 minus 3, because this is plus, which will give you 10. So 1, 2, and 3 ions are all equal in terms of the number of electrons each one contains. Then, what if you are faced with questions involving electrolysis? First, microfaraday's law of electrolysis. The second law, you just use Ramit over Chaffer. You watch that video you are seeing there on the screen. I have an exclusive video for calculations involving microfaraday's first law of electrolysis. Then also, second microfaraday's law of electrolysis calculations. Calculations on solubility, the videos are all here on this channel. Thanks for watching. Please, you are going nowhere better than this channel as far as chemistry, biology related courses are concerned. I'm here to give you the best. Much love. Thank you. Good luck in your exams.